So good afternoon, everyone. Thank you for being with us today. My name is Sheila McElraith, and I'm a professor at the University of Toronto Department of Computer Science, a Canada CFAR AI chair at the Vector Institute, and an associate director here at the Schwartz-Reisman Institute for Technology and Society, SRI. I'm delighted to moderate today's SRI seminar featuring our distinguished guest speaker, Yejin Choi. Before we begin today's session, I'd like to take a moment to acknowledge the land on which the University of Toronto operates. For thousands of years, Toronto has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to live and work on this land. While some of us may be joining from different places today, we invite you to reflect on the history and the relations of the land you are on. A few logistics before we begin. For those of you who have participated in the past, you probably already know this, but this session is being recorded. Our speaker will present for about 55 minutes, and that will be followed by a Q&A. During the Q&A session, I'm going to encourage you to please turn on your cameras if you feel comfortable, and also use the raise hand function in Zoom to indicate that you have a question or to type your question into the chat, and you will be unmuted when it's your turn to speak. So without further ado, I'd like to introduce today's speaker. Yejin Choi is the Dieter Schwartz Foundation Professor in the Department of Computer Science at Stanford University. She's also a senior fellow at the Stanford Institute for Human-Centered AI, Stanford High. Previously, Yejin was the Wissner-Slivka Chair at the Paul G. Allen School of Computer Science and Engineering at the University of Washington. Yejin's research is quite broad in scope. She explores the fundamental limits and capabilities of large language models, novel training approaches for small language models, neuro-symbolic integration, common sense knowledge and reasoning, moral norms and values, pluralistic alignment, and AI safety, among other topics in that general milieu. Yejin has a number of honors. She is and awards, and I'm only going to mention a subset of them. So in 2022, excuse me, she was named a MacArthur Fellow, which is a highly prestigious honor. In 2023, Time named her one of Time's 100 most influential people in AI. She's a co-recipient of 2 Test of Time Awards and 8 Best and Outstanding Paper Awards from leading AI conferences. And she also was recently named a Schmidt Sciences AI2050 Senior Fellow. We're excited to have Yejin with us today, and we're very much looking forward to her presentation, which is entitled The Enigma of LLMs on Creativity, Pluralism, and Paradoxes. Yejin, over to you.
Thank you so much, Sheila. This is such an honor to join this SRI seminar series today. And I would like to share what I'm confused about LLMs these days. So starting off from creativity, there was this panel now about 1.5 years ago, I think, at Simon's Institute about LLMs. This, I think, was after ChatGPT, we gathered to discuss what we feel about it. Oh, I see in the screenshot there's Ilyasus Kiefer as well. Of the things we discussed was creativity. In particular, I asked this, it so happens that the panel was not necessarily about creativity, but we arrived at this topic, which is characterized as a Hemingway thought experiment that I asked at that time. What I mean by that is, suppose LLMs are trained on all text on the internet, minus the work of Hemingway or any other authors influenced by Hemingway's particular writing style that comes across as very crafted. Could LLMs, if scaled up sufficiently, achieve that level of creativity? And one way to think about it is interpolative versus extrapolative novelty. Though I'm hand waving here, admittedly, what I mean by interpolative and extrapolative. In my experience, when talking about these things with others, either this makes total sense right away, or it's all too hand wavy. I don't have any better way of conveying this though, so I just admit that this is hand wavy. The panel quickly drafted away from that conversation, but Shafi wanted to get back to that discussion. And so this question really asks whether there might be fundamentally different types of creativity and whether there's any limit to Gen AI's or LLM's creativity in general. And a lot of people seem to think there's no fundamental difference. Of course, LLMs can do this. Just give more compute and more data, it can do it. But I think some people, I think including Shafi, feels that there might be fundamentally different types of creativity that current recipe of LLMs cannot really reach. Well, I'm biased toward that answer as well. But I think it's understandable why some people feel there's no limit with LLMs or Gen AI in general. And here's one example that people like to use. AlphaGo's move 37 is the reason why people feel there's no limit, because this came across as such an incredible move that humans couldn't come up with. It felt so unique and creative for human experts. So since AI could do moves 37, it must be also that it can do anything else that's really beyond our imagination. There has been papers like this, Transcendence, how generative models can outperform the experts that train them. This was also based on, I think this was based on chess game playing. And when we read paper titles like this, again, we come away with this impression that there's no limit. By the way, if you read this paper, the transcendence in this particular application comes from being able to take interpolation or average movement across a different chess movement. And it turns out that if you're able to take averaging really well, then you tend to win the game. So this is not really extrapolative transcendence. This is more like interpolative transcendence. Now, we can also think from Jan LeCun's perspective. He said current LLMs are trained on text data that would take 20,000 years of time for one human to read. So that's a lot of text. So he said this in the context of how LLMs are inferior to us because it takes too long for humans to read everything that LLMs do need to read in order to compete with us. So we are more data efficient. But we can also flip this around to wonder whether, could LLMs in principle reach a much better level or new level of creativity by standing on the shoulders of giants, which are humans? So again, these are a little bit confusing because it seems like we have different evidences that seems to suggest that maybe LLMs could really be better than us. And then there's even this scientific report that says, oh, actually, for tasks that require divergent thinking, LLMs are better than us, according to some researchers. Yet on the other hand, some colleagues, collaborators and myself, including Tom Griffith at Princeton, who's among the top cognitive scientists, we had this paper about using LLMs or challenging LLMs for creative problem solving. So in this work, we are trying to look at situations in which we don't have the right kind of tools available for us, and you have to use different tools to solve a given problem. So, for example, imagine that you need to roll out dough and you don't have the roller for the dough. Then what do? I would probably pick the wine bottle. Um, but LLMs suggested to take the cotton towel and roll it up tightly, which I guess in theory, the shape-wise, it would be the right kind of thing to do, but it's not going to be hard enough. So you kind of get the point. And when we test human performance as well as various LLM performances, so this too much information, and I would just say that green means you're doing well, and red means you're not doing very well, and different columns correspond to different LLMs or humans' performance. So the more green, the better, and the best the best performer is humans, sort of like voting-based human performance as opposed to LLMs. So LLMs do really well against the humans, but there are more nuances when we look at this more carefully. Anyway, so going back to this Hemingway thought experiment, unfortunately, I cannot answer this question for you because I don't have the kind of resources to do this experiment, because this requires taking all the pre-training data, which I don't have, throughout all the Hemingways and then retrain. So we cannot do that, but we wanted to see whether we can answer or make a one step toward answering that question somewhat indirectly. So we have this new paper to show up at iClear this year about quantifying surface level linguistic creativity of language models by systematic attribution of that text against the web text. So imagine you ask the following writing job to ChatGPT. Write an abstract for a paper with the following title: Poetry Will Not Optimize, or What is Literature to AI? ChatGPT wrote the following paragraph, which is pretty good. So it says, the advancement of technology has led to the integration of artificial intelligence in various fields, including ... However, the question remains, can AI... so what you see here is all the colored parts exist on the internet. The red part is verbatim matching, whereas the purple is near verbatim. So into the complexities of poetry and the limitations versus about the complexity of poetry. So we found that a lot of this really amazing, seemingly fluent text actually exists on the internet. You know, it doesn't necessarily mean that ChatGPT copy and paste from this, because it probably generalized, but it's interesting that all this fluent text came from the internet. On the other hand, this is actual abstract by Michelle Elam at Stanford. She's a professor of literature. So her writing is more unique. We cannot really trace her writing back to internet as much. Well, there's some portion that does exist, but that portion, if you look at Purple, for example, like large language model, processing model, this is just generic text, not like really the key part of her content. So we did this. I'll skip this part. Yeah, this is using GPT-4 instead of ChatGPT, which is a bit better, but still GPT-4 is worse than, let's say, Michelle Elam. We also did this for Hemingway novel. So The Old Man and the Sea starts with the following sentence. He was an old man who fished alone in a skiff in the Gulf Stream, and he had gone 84 days now. So we didn't say that this is Hemingway book, but GPT-4 definitely read it. So it starts right off with Santiago, which is correct name. But because it's sort of like maybe, yeah, for whatever reason that we don't know, it doesn't really verbatim generate this. Actually, if we ask it to verbatim generate the first paragraph, it will do that. But in general, it tries to paraphrase. And it paraphrased in a way, in my opinion, it got worse. So actually, let me highlight some of this. So what did it say? A man of the sea, tale of storms, weathered and battles with, rise with the sun, a silent silhouette against the soft pink hues of dawn. So depending on your taste, this is great, or this is worse than original Hemingway, which again is much more unique in his writing. By the way, we did duplicate removal so that we don't attribute Hemingway back to his own writing. So, because that would be silly. Of course, Hemingway exists so much on the internet. All right, so what we do then is to look at this portion of a text that is colored versus not. And based on that, we derive this creativity index, which basically looks at how many n-grams are unique. And, what should be the minimum n-gram we should check? That's an empirical question. We don't know, but if you fix L to be 8, for example, then we can compute this for you. So I haven't explained how we do this efficiently, because this can be quite compute intensive job to do. But by changing the minimum n-gram length L, we can also look at this curve. So there are a few caveats that are important to keep in mind. First of all, creativity is in the eyes of the beholder. This is true among humans as well. Sometimes you like just different art. That's okay. In this particular study, this is in the eyes of the data, because depending on which data we check against, a text might look more creative or less creative. The smaller data, internet data we check against, of course, creativity will look more inflated. So whatever we compute, because we had limited access to the internet data, our measurement in general is a little bit inflated. Also, we don't have access to the post-training or alignment data. Therefore, I would expect that this measurement is inflated. Okay, so how do I do this computationally efficiently, though? Because checking this verbatim or near verbatim literally can be a very expensive operation. So I just give you quick intuitive overview without going into the detail too much. But the verbatim matching is based on our InfiniGram technique that I will briefly mention in a bit. And then near verbatim has something to do with the world mover's distance based on word embeddings. Whichever we use as underlying matching technique, we still need to do this over the sliding window of text spans efficiently, which we do this by having the text the document we need to check against the internet. So there's like internet portion, there's the input portion, and then we do basically a simple version of dynamic programming to have a sliding window checking whether we checked certain n-grams or not. So in general, we found that LLMs, at least ChatGPT, isn't as creative as expert human writers. So we're not comparing against average human writing, but more like famous novels or famous speeches of historical figures or poems. But in general, we found that at least in that domains, humans are better than ChatGPT. Skip this. We found also that models after alignment or RLHF have reduced level of creativity, probably because they now LLMs speak more like lawyer style guarded language that's like uber polite. And so that's a little bit skewed distribution, and we found it becomes less creative. Among human writers, different human writers, we also see like different patterns. The more famous classical writings seem to be more creative relative to novel, newly rising writers who are not yet broadly recognized yet. Though, I mean, one could also argue that these really famous classical writings also are coming from different era and had a different style of language back then. So those factors might conflate the interpretation. Creativity index can also be used for zero-shot machine text detection, because it turns out different LLMs have somewhat different writing style. And if we have enough corpus built from a language model, we can do this creativity index measurement against that LLM's own text. So if we do this, then we get machine text detector as well. I'll briefly mention that there's this web interface where you can try out creativity index in real time. First, on the left, you need to fix which corpus you want to check against. Usually the larger the better. And the largest is still not large enough. It's only like about 3 trillion tokens or less. And then for the input, we put this like Surya Ganguly's example of, I think this LLM writing a poem in the realm where stars do hang and planets dance, etc. It sounds very nice and it's amazing, but some of these shorter engrams did appear on the internet. As you change engram length longer, you start having less text covered. So corpus used in our interface, though, is likely to be too small for the frontier models, which have seen, we suspect that it has seen way more internet data than what we used. So there's that. And also there's a potential gap in the data cutoff time. And so if you're checking the creativity level of a document written very recently, it's not part of our corpus, therefore it's going to look more creative. All our experiments do remove duplicates during DJ search, but the web interface do not do that because that's very slow. So please keep in mind, if you try Hemingway, it's going to not do duplicate removal against the Hemingway. So this demo shows that DJ search is only, the web demo only shows the verbatim matching without the near verbatim. So the web demo is a little bit less of what we actually report in our paper. Okay, so next let me explain what InfiniGram does. So this is our paper from last year. And here we wanted to see whether we can make the classical statistical n-gram language models relevant again, because these days nobody does this anymore. But in order to make it relevant, we need to make n very large, like infinite. And we also want to be able to do this over very large corpus, like maybe 3 trillion of tokens. We achieve this without any GPUs, because GPUs are so hard to get these days. And n-gram lookup speed will be super fast. So the way, by the way, just to explain how hard these desiderata are, let me first mention that if hypothetically you want to index 5 trillion tokens via classical, statistical n-grams, then roughly you might be looking at 2 quadrillion unique n-gram tokens, up to 5, actually, yeah, not sure up to what n-gram, but maybe up to 4, I'm not sure. But anyway, so that might require like 32 petabyte disk space to store. And so this is too resource and compute intensive. As a result, the biggest n-gram language models built and shared in the community was maybe from 2007 by Jeff Dean and other colleagues at Google. I mean, they probably internally had something larger that they were not going to share, but at least what was publicly reported was based on 2 trillion tokens, which included 300 billion unique n-grams up to n equals 5. So it was A, short n-grams, B, over 2 trillion tokens. Is it possible that we can do longer n-grams? So it is possible. And first, let me tell you that there's a web interface you can play with at infinigram.io/demo if you like. There you can find, okay, on the bottom, you see this weird word. It's actual word that has 45 letters and 17 tokens that you can search. I don't know how to say this, but this weird word does exist many times. In fact, more than 3,000 times on the internet. And so you can search this at this online demo, and the latency is like 5 milliseconds in this case. It also shows how exactly you should tokenize this word. You can also search n-grams with longer n, like actions speak louder than, and you can choose to see which word comes next, or you can just check the exact count of this. So there are multiple functions that this interface will support. So how did we do this? So given a text corpus, we're going to build a suffix array. So the given a corpus, what this data structure does is there's rank and there's a pointer. Rank is just increasing number that indexes the location of the word in that corpus. So this is just increasing. So what we really just store is the pointer. The pointer stores where the University of Washington, for example, might begin in the corpus. So once we have this suffix array built, then what we can do when you ask about how many times University of appeared, we just find all these indexes of where in the corpus this particular string might begin, and then retrieve them and count them. Only after you ask me how many times a certain n-gram occurs, we then start counting on the fly. We don't pre-count, we only count on the fly by using this suffix array, which just tells you where particular beginning of n-grams exist. And by the way, for visualization, I'm showing, University of Washington, the suffix array content, which might contain University of Washington, followed by Bob works at university, or Charlie teaches at university, etc. But we don't need to restore this text portion. We only need to store the pointer locations of these different indexes. And these are the n-grams in the lexicographical order. All right, so we only need to recap, we only need to store the suffix array, which is just what's shown on the bottom, basically. That's just like a pointer, the column that stores the pointers. We don't need to store anything else. And using this, you can kind of like revisit your original corpus on the fly in order to do this n-gram computation on the fly. If you do this using C++ coding instead of Python, you can actually code this up such that the lookup efficiency is really fast. And in general, our code can operate under 100 millisecond delay for counting things or computing the probability or looking at which word comes next. And no GPU necessary. This is all just CPUs. we can also use this in order to improve your favorite neural language models by interpolating your neural language models probability distribution with our n-gram, InfiniGram based distribution. So we found that if you do that, you get performance gain across the board, at least at the level of GPT-2 and Llama 2. Right, so we also serve API point and not just a web interface, but you can also access our APIs programmatically and across several months of time. I think now we served a lot more than 60 million API queries, but at the time of like several months into releasing this, a lot of people queried our interface. So that's the end of InfiniGram for now. And then next move to the pluralism part of the talk. So the underlying thesis of this talk is that we humans are all different, and that's a good thing as opposed to bad thing. In fact, imagine you invite the speakers and they all say exactly the same thing, and you can predict exactly what they're going to say next because they're all the same and similar to each other. They totally agree with each other. Nobody has any disagreement. That'll be very boring seminar to attend. And so then AI should serve all humans who are different from each other, ideally, versus serving humans that versus humans serving AI. That's a different story. AI serving AI, or AI serving only some humans, or humans that are better represented. There's this interesting book, Noise, by Daniel Kahneman and others. And I really like Daniel Kahneman's book, Slow, Fast, the System 1, System 2 reasoning book. But this Noise, I don't know what to think about this one, because the book is concerned about the following observation that, two doctors in the same city giving different diagnoses to identical patients, or two judges give different sentences to people who committed the same crime, and to interviewers making different decisions for job applications, or two professors admitting making different admission decisions for identical applicants. Now, if you put it that way, it sounds horrible, right? But so they say, the book says these are examples of noise. This is horrible. Variability is bad because we should have made all the same decisions. So if you put it this way, yeah, it sounds like it's bad. So the book goes on to suggest that there may be different techniques to reduce that noise, and perhaps the use of AI algorithms could be good to reduce the noise. But I don't know whether that's actually a better world per se. Like a PhD, the mission, done by AI that has the same equation to maximize, why do you even apply anymore? No need to apply. You already know the answer. I think it's a pretty horrible world. Or, you do the job search and it's all determined. It's all deterministic. I think it's a pretty dystopia in my mind. I think it's nice to have some randomness, or nice to have some differences. So apparently there's philosophical support about this variability. So Baroness Honora O'Neill, British philosopher, also serving for British crossbench, had this talk about how variability is a feature, not a flaw in human judgments. In fact, she cites the critic of judgment by Kant for this purpose, who discusses different types of judgments. Maybe there's this particular kind of judgment called the determinant judgments, where maybe AI can be a little bit more applicable, relatively speaking, but there are other types of judgments in which it's not clear whether the use of AI, in a traditional sense at least, is the right approach, because there are truly situations in which there's no gold answer, and it's good to have variability. And sometimes it happens because there are conflicting values at us. So AI agent or human agent might want to be kind, but and this agent might also want to be truthful, but sometimes telling the truth may make you unkind. So there are situations in which values are at odds, and there's no clear one gold answer. Depending on what you want to prioritize, if you want to be really truthful, you might just tell very rude things to everyone around, including your friends. I mean, if that's what you choose to do, that's what you choose to do. But, a lot of us rather want to be kind to each other. Want to go on, you want to go to vacation, but you also want to be nice and donate to a charity, but you cannot afford both. And what do? Like, is donating no matter what is the correct thing to do, but you also have the right to enjoy your life or be kind to your family or friends to go vacation with. And so importantly, there are genuine situations in which variability is a feature. Okay, so having said that, the implicit assumption in RLHF up to this point has been that there's a single set of values or preferences to which we should align. Because in the end, even if that was not what people intended to do, implicitly what people end up doing when you optimize that reward function is that you end up doing exactly this, which is, you try to optimize for the majority groups, or most preferred, most common ways of doing preferences. But in reality, we are all very different. So this now raises a serious challenge about what to do with differing preferences. And so there have been a lot of great work about this, that perhaps we should do distributional preference learning, jury learning. And so my talk goes into this line of research. And our first sort of like a paper in that direction was only last year, where we discussed this roadmap to pluralistic alignment. So I'll briefly, and since then, by the way, the field these days moves so fast. In this paper, we proposed this notion of pluralistic alignment together with the three different types of alignment techniques, which includes distributional alignment, overtone alignment, and steerable alignment. I will talk about what they are in a bit, but soon after, a lot of people already start writing papers about how to do it. So this is really amazing. Let me mention a little, describe a little bit more about what we proposed in that work. So this work was inspired by this Dadlus article by philosopher John Tashulas, who discussed how ChatGPT might amount to preference-based utilitarianism, and a more humanistic approach may need to prioritize three things: pluralism, procedures, and participation. Of this, we thought, okay, let's focus one thing at a time and think about pluralism. These three things, pluralism, procedures, and participation, I think are kind of interleaved though, and requires more thought to think about how to approach this computationally. But we wanted to start with one thing, which is pluralism. So three types of pluralistic alignment: overtone, steerable, and distributional. And what we mean by that is the following. So overtone pluralism is when, for example, imagine this trolley situation, you ask, hey, what should I do? Instead of saying one gold answer, under overtone pluralism, we should think about different perspectives, like utilitarianism perspective and deontology perspective and virtue perspective. And depending on different perspective, there might be different answers. So you lay out all of them. So overtone is to demonstrate all the reasonable answers that people might have for any given problem. Steerable, on the other hand, is more about, suppose I want deontology. And under that context, what should the answer be? So steerability is about how you can control the LLMs to serve your own value system better. Distributional is the case when it's more about decision-making scenario. So you can imagine that sometimes AI just have to make a decision. If AI has to make a decision, then at least we should think about how to make AI not to make systematically the same decision over and over, but make decisions that mimic the distribution of opinions that people might have. So even for the PhD applicants or job applications, instead of hiring the same person over and over, or people with exactly like identical background over and over, perhaps AI systems should make decisions that follow the distribution of human decision making, including the minority decisions. And by the way, none of this is perfect, and there may be different kinds of pluralism we should think about, but this is sort of like what we began with. I think I'm going to skip some of this, but not surprisingly, we found that LLMs, are good at some of this, not good at something else, and especially after alignment, distributional pluralism is hurt. And this is just as expected. We just measured and found that alignment basically skewed the perspective. And currently, this aligned models serves the left-leaning perspectives really well. So if you happen to align with that, then you may seem like, oh, this is how things should be. But you can also imagine that people who are not happy with that can make the opposite kind of biased LLMs. So just biasing the LLMs into your own perspective is not the solution. I think we need to have a better way of thinking about this. So there's a lot more work to be done, but we had one such attempt, modular pluralism, to seek pluralistic alignment by having multiple LLMs to collaborate. So we build on community language models for that purpose. What we mean by community language models is literally the community of different language models specializing on different cultures, different languages, or different sizes, different purposes. So once we have that community of language models, then we can use them to serve these three different types of pluralism: overtone, steerable, and distributional, as follows. So let's start with first set up this. Okay, for community language models, you might have like 6 Hugging Face downloaded from Hugging Face, 6 language models, your favorite language models. And then there might be one large language model that interact with this community of smaller, or it could be large language models, but community of language models. So if you have that for overtone, what we can do is you ask different language models about their opinions about a particular question, and then use one large language model to look at all these different opinions and then summarize all these different opinions into one answer. So large language models these days are very good at this kind of a summarization task. For steerability, instead of asking all the language models, we can ask the subset of community language models that are better aligned with the steerable properties that we should better respect. So we could use large language models to summarize only over that subset of language models output. For the distributional case, what we can do is we ask individual language models to make a decision. And then depending on the distribution of different decisions these community made, then the large language models might make decisions reflecting that distribution. So this is a fairly straightforward approach, but we found that this approach works quite well. The paper shows a lot of experiments, but I will just highlight very few of them. So for example, if you want to do this, if you want to align your model better to Japan, India, Nigeria, Kenya, then indeed we find that compared to not doing anything and just using large language models as is versus having this community specializing model being part of the pool, and you definitely get better results. Skip this experimental part and then move to the last part, which is the paradoxes. So one interesting, well-known paradox that existed before is Moravec's paradox. So our work is inspired by this, which said, contrary to traditional assumptions, higher level reasoning requires little computation, but sensory motor and perception skills might require more enormous computational resources. So in some sense, this is right in the sense that we have AlphaGo, we have AlphaFold, we have AI beating humans on maybe math Olympiad solving, but we don't have robots that have motor skills that are more superior than humans, or house cleaning robots that clean the house for you. Yeah, we are kind of in a similar funny situation in which AI just does better for intellectual jobs than very easy physical jobs right now. So there was that, and we had this other idea, related idea, but very different idea called the generative AI paradox. What it can create, it may not understand. This draws a parallel to what Richard Feynman said. He said, what it cannot create, I do not understand. Implying that if you can create, you do understand. Except, I mean, that's what Richard said, but it doesn't seem that way with generative AI. It seems like what it can create, it may still not understand. So the paper provides more formal definition of what we mean by that. But roughly speaking, what we mean is for generative models, hard can be easy and easy can be hard compared to humans. And in particular, for humans, generation of text can be harder than understanding of text. Generally, reading is easier than writing for humans. I can read Hemingway, I cannot write like Hemingway does. Whereas for AI, that might not necessarily be true. I'm not necessarily saying this is completely reversed, but it's just that it's not as straightforward as we think. So here's one example. Draw a photorealistic astronaut doing a plank on a table. If you ask me to do it, I would say, I cannot do that. I cannot draw anything photorealistic, whether astronaut doing a plank on a table or not. But for Gen AI, super easy. So it generates, oh my goodness, look at this. Like it generates all these very photorealistic images. Amazing quality, except some of them are not quite right as far as they're all astronauts for sure, but they're not on the table. Some of them are not on the table. So if you ask me which one is correct, then, oh, that's super easy. This one is correct. But Gen AI may not know which one is really correct, which is part of the reason why it's generating a lot of these funny other examples. And then you have to do the job of selection. That's really quite curious. Why easy is hard and hard is easy in this case. So turns out when you use GPT-4 to write a simple story, like in this case, we asked it to write a 2-paragraph story about 3 people building a house. It's super good at generating a story. How about that? And if you ask a question about that story that it just generated, usually it answers it correctly, but there are cases in which it does get confused, even with a simple question like how many total designs were sketched in the story. GPT-4 says only one design, but that's not true. It itself said multiple designs in the story, but it's answering this question incorrectly. Importantly, by the way, if you ask very straightforward questions whose answers are written in the story, then GPT-4 is very good at answering all of them super correct. If you ask questions that requires a bit of a synthesis of information, that requires, combining bits of information, then it's more likely that, or relatively speaking, more likely that it's going to make a mistake. And these are the kind of mistakes that are less likely for humans to make because these are very easy reading comprehension tasks still. All right, so we did a lot more comprehensive studies around this where given a QA problem like this, Austin had a rough day at work and decided to go to bar. Why would Austin do this? We found that so there are a lot of these multiple choice questions as benchmarks that people use. We found that if you test ChatGPT or LLMs in general in a open text QA setting instead of a multiple choice QA setting, then it might actually perform better. Oftentimes it performs better in that setting as opposed to multiple choice setting. And that's a little bit different from humans in the sense that we usually prefer multiple choice questions when we take exams, because then we can get lucky. Sometimes we forget the answer, but if the answer is provided among the choices, then it's much easier for us to get the correct answer. But we found that for LLMs, it's a little bit reversed. It's not completely reversed, but it's definitely the direction is different from how humans would prefer discriminative evaluation over generative evaluation. Okay, so after this study, there were many other paradoxes reported, including the generative AI paradox in evaluation, that what it can solve, it may not evaluate. It's kind of similar story that even though LLMs may be good at solving something, it doesn't mean that it's a reliable evaluator per se. Oh, I recently also saw similarly spirited paper about debugging software code where LLMs may not be able to find a bug. You know that it's there, but LLMs might say there's no bug. But if you insist that there's a bug and ask it to fix it, then it may be able to fix it. It's just not able to locate the bug and identify the bug. So it's a little bit similar that it may be able to generate the answer, but it may not be able to evaluate. There are many other similar papers, but here's another one. This says when you ask LLMs to come up with inductive hypothesis, so there may be like puzzles, and there may be underlying inductive hypothesis that explains the puzzle. And so for inductive reasoning, we found that language models can generate hypotheses quite well. It generates a lot of wrong hypotheses, but it's very good at generating so many of them so that some of them are correct, but it's not very good at finding which one is correct. And for humans, it's the opposite. For this particular domain, humans may not be able to necessarily come up with a good hypothesis, but if it's provided to you, it's relatively straightforward to verify whether hypothesis is good or bad because it's just simple like rule checking for us. So we found that this is reversed. And some of these revolts are, I think, leads to the phenomenon that's counterintuitive, including what this paper reports. So the reversal curse, where LLMs trained on A is B might fail to learn that B is A. So what kind of A is B? Here's one example. On the bottom of this abstract, there's something about who is Tom Cruise's mother, Mary Lee Pfeiffer. So, I never know who Tom Cruise's mother is, but let's just say I memorized it. Then if you ask, oh, who is Mary Lee Pfeiffer? Then I can reverse it to say, oh, that's Tom Cruise's mother. But this kind of obvious generalization may be surprisingly hard for large language models. In this case, even GPT-4, they reported. So there's a jailbreaking paradox. I think there are more paradoxes these days about this, but the bottom line is that as LLM capabilities really increase and advances, we humans like to jump to the conclusion that it's going to be better than us for everything. And yeah, it's very surprising how LLMs, on one hand, advances really fast, but on the other hand, still has strange weaknesses that we don't yet fully understand. So that adds to the series of enigma of LLMs, and I'll stop here.
Thank you very much, Yejin. That was really super interesting. We're now going to move into the discussion period and welcome questions from our participants. So for those of you who are on joining us today, if you'd like to ask a question, please use the raised hands function or the chat function in Zoom. Ideally, and please turn on your cameras if you feel comfortable doing so, so that we can have a more fulsome and social discussion. I'll try to watch the chat, but if I miss you for some reason, please do speak out. And so let's just start things off. I'm just going to check to see whether anybody has their hands. Yep, we already have quite a few questions. Okay, I'll start. I'm just going down the list in the participant list in that order. So Torrin Clausen, you can begin. Thank you. And someone will unmute you. You're not unmuted yet. Yeah, there you go.
Yes, hello, thank you. So my question is about the first part of the talk about your creativity index. So have you or anybody else tried to optimize for this? Like it seems like it should be possible to modify a language model and put some filter on top of it to make it generate sort of unlikely n-grams. And would people perceive this as being creative or of any sort of literary merit?
Oh, yeah. We didn't try ourselves, but I imagine that if you do, then you can probably produce text that looks more creative at the surface n-gram level. Whether that actually leads to literary quality, I doubt, because I think usually, at least my somewhat naive understanding of artists doing art is that they usually have their own individual taste and style that they're trying to convey repeatedly. So there's a theme that they're trying to convey through different pieces of art. And whether what it is, inventing that for the first time and then consistently carrying that out is not part of probabilistic language models learning objective, nor the n-gram surface level creativity. So I suspect that probably it's not going to work. But when we ask just like, lay people's opinion about, oh, does this look super impressive? Then as far as that perception goes, I imagine that probably you get higher evaluation.
Thank you, Julia.
Hi, thank you so much for the talk. That was great. So I also have a question about the creativity measure. I guess like this is sort of two questions. One, I'm a little bit worried that creativity in the way that you've been talking about it is kind of blending with something like aesthetic value. So you might think people can be creative as in the examples that you provided as problem solvers or as scientists forming hypotheses and things like that. I understand that in the text case, maybe what we're looking for is something like aesthetic value, but just to have that in the background as a thought. And then here's sort of a question, which is about using engram. And I know that this has to be sort of like something that you can like code up or whatever, but coming from a philosophy background, this is like sort of my concern. So there's this like famous case from Borges. He has this story called Pierre Menard, author of Don Quixote, where he imagines this man, Pierre Menard, who rewrites Don Quixote word for word. And then the idea is supposed to be that he does it with different intentions than the original author of Don Quixote did. And so it's supposed to be this sort of like entirely different work, despite having exactly the same written content. And that's the way a lot of people interpret it. So you might think, oh, intentionality or something like context change actually contributes like to the majority of the creative content. So you might also think of Andy Warhol's famous Brillo boxes. They look exactly like a Brillo box, but the point is that they're in a new context, and the creativity comes from that sort of like intentional use of them in that context. So sort of question one is like, I don't know that that's the like sort of whether words are used, the same words are used as like, or the same engrams are used or something is the right measure. And then also I'm a little bit worried about the holistic aspect of it. So you might think it's not just about the quantity, but it's about, if there's one word in the middle or a couple engrams in the middle or something like that, that's different, it could make the whole text radically creative. So yeah, just sort of thoughts about that from the philosophy side of things. Thanks.
Yeah, no, thanks for such a thoughtful question. I totally agree with you that what we measure is very surfacey and very limited. Perhaps I should share a little bit more context about why we even did such a surfacey and incomplete measurement of creativity in the first place. And that's because I was in that panel that I briefly mentioned earlier. And some people feel like LLMs got everything. It's gonna be better than us for sure. And oftentimes that's because look at how amazing text it's able to generate. It's just so good. It's like a lot of people said it's better than what they can write. And probably there's a truth to it. And maybe they are right that, LLMs are better than all of us, and if it's not yet, it will be, some of these people are very sure that for sure, it's just, matter of 2-3 years of time when LLMs are better than all of us at everything. I was curious, why is it so good? Is it possible that there's something that it's not as good at as we imagined it to be? And especially that creativity capability is so praised. I wanted to find the flaws in some limited ways. But although we found some flaws at the surface level, we don't yet have the tools or quantitative measures of going deeper aspect of creativity. And honestly, I'm not sure what the if it's possible even to come up with computational solutions around it.
David Glukov.
Hi. So thank you again for the talk. I feel that there is something kind of a bit almost like oxymoronic in the presentation, in the sense that in the start there is sort of, okay, generative models are lacking in creativity, and at the very end of the presentation here is a bunch of paradoxes where models are generating things that are not correct, but in that sense are also novel. So for example, in the image generation of the astronaut on a plank on a table, a lot of those images would be, in some sense, very creative and completely novel. And so there is an element, or similarly, if you're asking the model to generate code and it generates bugs, those bugs in themselves become a feature of novelty. And so then, to me, it seems like there is sort of this like discongruence of what exactly is creativity versus sort of this correctness. Is the creativity actually in the generated content, or I think as the previous person talked about, kind of the intent or the desire? So like, was the prompt provided to the image generative model the creative, actual the component of creativity? Was it the generated images? So is it sort of that maybe like some of the pluralism or like diversity, is it really that there's randomness in the data that we want to capture, or is it some randomness in the underlying intent? That the data has to be correct, but the intent has to be sort of diverse. Maybe this is towards like steerable pluralism and so on, but the idea that like the human kind of creates a desire, the human wants an astronaut on a table, that would be the source of the creativity. And the real question is essentially what a model can generate. And that failures of the model to be creative in their outputs, for example, in these engrams, might be more of a lack of under-specifying the desired output in the prompt, rather than like a problem of the model's sampling, let's say, or the generational capabilities.
Oh, wow. Thank you so much for, that's a fun question, drawing very creative connection between creativity and pluralism even. And I think it's a very layered question, so let me answer bit by bit. But first of all, your comment that the talk has oxymorons and congruity, and yeah, 100%. It's full of that. That's why the title is the enigma, and I honestly don't have answers to this, but even for the creativity part, I wanted to actually acknowledge that, although maybe I realized I didn't do that clearly, which is that LLMs are really creative in some sense. It in many, at least like I seem to get people's comments, left and right, that they think LLMs are very creative. So at some point, I mentioned that creativity is in the eyes of a beholder. To me, what ChatGPT wrote about AI and poetry, that language is not up to my. I mean, it's not like I can write like that, but nonetheless, it's a little bit much to me. But, some people is wowed by that. Like, wow, look at this. It's so nice and so creative. I like it, So I realized that it's really in the eyes of the beholder. I like particular kinds of drier, more low-key style personally. And ChatGPT writes text that's too flowery sometimes. If I try to use it for letter writing purposes, I feel like it's too much. It's not me. But this astronaut image, for example, it does bring in certain kinds of novelty still, like that people may have not done it before. And then there's this question of like creativity coming from intent versus maybe execution, and maybe humans should have provided more details about what you want. And from artist perspective, I can totally imagine that some might just like 100% agree with you, and then some might view this as more like collaboration session where I don't want to specify everything. Why don't you inspire me by throwing some randomness back to me? About creativity, the tension between creativity and novelty. I once read a book about creativity by someone at UPenn. I wasn't ready for this QA, but hang on, do I have this book here? There's a book by maybe Kaufman. Actually, I wasn't ready for this, but there's a UPenn psychologist who wrote a book about creativity, I believe. And in that book, he says creativity requires being able to generate a lot of candidate, ideas, but also be able to filter out the nonsense or low value items. Somehow it's only creative when there's like a novelty, but also value to it. Like it cannot just be novelty for the sake of being novel, but it has to have, maybe it's the intentionality. Maybe there's some other like messaging that, one wants to do, but whatever that is, it has to have a value. And who should give, human should give or AI can contribute? I don't know, but I tend to think AI might have a potential to fill in the gap of human creativity, despite what I said, that AI doesn't seem as good as some human writers.
Thanks, David, for a great question. Next up, we have Ella.
Hello, thank you so much for this interesting talk. I really enjoyed it. I have some questions, like regarding creativity again, and a more general question. So first, for creativity, because you considered engrams, and is it mainly for text creativity? Or how about other types of creativity? And the other thing is that do you consider hallucination a kind of creativity, if you can say that, create something so much new that is not based on what has been trained of or have seen before? And my last question is regarding, you mentioned about that LLMs cannot be as good as in creativity in comparison with very creative persons, and also it might not be good in evaluation and judgment. So if you want to categorize it based on the LLM's functions, based on the brain cognitive functions, can you do some kind of categorization of that comparison?
Yeah, about your first question, how about maybe images or other modalities for creativity? I think they'll be really great. There might have been some such work, but yeah, like I personally also wanted to see whether, given, photorealistic astronaut image, whether it's possible to attribute it back to internet images in a piecemeal manner. To see whether it's actually as impressive as we thought it was. I imagine that something like that could be computationally possible with some effort. What was your second question? Sorry.
It was regarding hallucination that LLMs have, and can we use it for creativity, like to see creativity as something that does not exist before?
I see. Yeah. So hallucination has a value only if in a storytelling where you're supposed to make up some situation that never happened, then it does have a value, but otherwise in general it does not have value. So like by this UPenn researchers' definition of creativity, something is creative only if it has a value. So in a factual setting, it does not provide a value, it's just a nonsense. And third question was about
it's about like comparing your whole research to the brain cognitive functions? Because you mentioned different aspects as judgment, evaluation, understanding. You compared these LLMs. Did you make a more general categorization on these functions?
Probably, yeah. I didn't go that far, but that seems to require more research and thought. Sorry, I don't have something too smart to say about that direction, but I think I would love to see research that tries to better understand or characterize what different types of creativity and what types of creativity is surprisingly or not surprisingly easy for generative AI when provided with a lot of internet data versus what kind of creativity might be harder for them to achieve if there's any limit whatsoever. Because, there's a debate about whether there's a limit at all. Some people feel there's a zero limit.
So thanks, Ella, and we'll go on to Betsy now.
Hey, thank you for the wonderful talk. I really appreciate it. I'm gonna actually stay away from creativity for this one question, if you don't mind, and go into the latter part of your talk about paradoxes. And my question is kind of what in the industry is really happening to address the various of paradoxes, especially in scientific research. So I'm more on the kind of scientific industry sector, and with innovations like Evo2 coming out with DNA predictions as well as like AlphaFold for protein predictions. How do you see kind of paradoxes play into kind of more scientific analysis? And is there anything to be done to address any of the scientific challenges in analysis to make sure that it is forward to the values and facts that is being done in recent research?
That's a great question. I think these sort of like paradoxes are important to raise the awareness about the fact that we cannot generalize from one capability to the other. And in general, these things require rigorous evaluations, but that does not mean that we can do wonderful things using AI as a tool, including perhaps like drug discoveries and scientific discoveries. I myself am very excited about that direction. And that's where we can really collaborate with AI as a tool, because AI can suggest a lot of hypotheses, which then do require very careful bettings, which humans can then help. And so because discovery, drug discovery, nobody just let AI on its own end to end discover drug and then, human take it, right? There's always like this long chain of like experimentation and validation and everything. But coming up with these ideas in the first place can be hard. So I think there can be good collaborative angle to be pursued. And how to design it has a lot to do with being well aware of where the limitations are and where the strengths are.
So we have about 10 minutes left before we stop at 2, and I'll take a few minutes at the end. So I'm going to try to get quickly through. We have probably more people who want to ask questions than we have time. So Mauricio, the floor is yours.
Hi, thank you so much for your presentation. It's really good. I have a question. In one of your slides, you mentioned Jan LeCun, something that he said that current LLMs are trained on text data that will take 20,000 years for a human to read. And then you have a comment that in the context of how LLMs are inferior to us, I didn't understand like the relation between that comment and what Jan mentioned. Can you elaborate a little bit more?
Sure. He wanted to say that not to say LLMs are better than us, but worse than us because it's not data efficient. But I was twisting it to say that for that reason, LLMs might be more. Some people might believe that LLMs are better than us because it may allow it to be even more creative. Because for humans, if we read a lot in general, our understanding as well as creative power does tend to go up. So the same fact can be viewed from two entirely different angles. But Jan LeCun's perspective was that therefore LLMs are worse than us.
So, Playmoon, floor is yours. Thanks, Deb, and thanks everyone for patiently waiting.
Okay. Thanks for the amazing talk, which made me think of many things. I have a rather personal question, please. To say a LLM is creative, I suppose it's not the same as saying a LLM thinks for itself or not, which I would assume is debatable. So I'm not going to ask you whether you think LLM thinks or reasons for itself or not. But I would like to ask you, since you are at the forefront of the AI, in order to qualify for a new AI model to prove that it may have its own thought or it has contextual understanding, or possibly just a little bit of self-awareness. In your opinion, what would such an AI must demonstrate?
Good question. I would be impressed by AI and start to wonder whether it has its own thought if I can interrogate for some time and really see whether it has its own stance, as opposed to keep changing depending on how I phrase the same thing from different angles. If it can maintain its own identity in a consistent manner and then really back it up, then that would be impressive. Usually though, LLMs don't do that. It keeps changing, like apologize and, try to please me. Going back and forth, yeah.
Thanks. Peter, you're next.
Thank you so much. That was inspiring, provocative. I work in the field of tech advising primarily on conversational and agentic AI, but I started out as a creative director working with agencies. So all the discussion on creativity was very fascinating for me. I was most struck by your comment around AI perhaps should serve humans versus us serving AI. And I agree with hype, like we see amazing possibilities. There was one observation, and then I want to get back to the point around AI serving humans that you made. But when I see a lot of the hallucinations, and I understand that it's trained on GPUs, it's facilitated on GPUs. The human brain, my undergrad was in biology. And so the human brain does some fascinating things when we dream. And so we're decoupled from the physical realm. It actually turns off the part of our body associated with the prefrontal cortex and these kinds of rules around the physical world. And so when I see GPUs, LLMs hallucinate, I think it's really amazing because it's actually doing what the brain does. It doesn't have rules around the physicality. And so your comment around like, it doesn't dance better than us yet. And it doesn't until it learns the rules around physicality and context of the universe, material sciences, and all of those things. So I think that's fascinating. And so I'm curious when it catches up, what will happen. But the thing around AI serving humans, it's a point of where I believe that humans can be augmented with AI, and I really love the point that you made. With regard to that, the relationships we have right now, even with coders, like junior coders are being laid off because expert coders have the expertise to actually edit. And so you were demonstrating that LLMs provide permutations, which are sort of logistically hard normally, but now that we have permutations, it takes the people who have lots of expertise and lots of experience to be able to edit that. So we're really good at editing, as you pointed out. And as a creative director, I've been advising the creative field of using AI. And again, like editing is fantastic. It's almost like having a team of interns in terms of the AI. But that being said, we're going to run out of people who actually have the expertise if they're not actually coming up through the system to gain the experience and the expertise. So I see that as a threat. And so I'm curious, I mean, with LLMs and AI getting more reasoning models, and reinforcing it with RAG, is there a parallel that you would recommend as a structure for human beings? Because we can only augment ourselves if we also live through life, live through these experiences so that we could gain the expertise. So we have a generation of people right now who have experience and have expertise and can use LLMs in the way that it should be. But we're going to run into a situation if people and society become lazy, they won't be able to do that. So I'm curious whether you have a recommendation, both from a technology side, AI side, and a social side, of how we could have an equivalent sort of reasoning and RAG sort of feedback model for human beings so that we don't lose the pathway to getting experience and expertise so that we can continue to partner with AI.
Yeah, great question. Great deep questions. I think we will have to, as the humanity at large will have to learn to have values over AI in the coming decades, if not even years. Like, what value do we add when we just keep calling ChatGPT for this and that, including, I don't know, homeworks and many other things in life? And I think using AI to speed things up is totally fine, but as a result, we will have to raise our bar in solving hard challenges for humanity, including, for example, even like starting with an easy example, like medicine. Medicine definitely can be better, right? I mean, oftentimes we have to wait too long before seeing a doctor, or they're too expensive, or sometimes I have like weird sickness and then doctors don't know how to diagnose. And there are many things unknown today that really could be better. And people can be served better, especially without insurances, or especially without enough resources. But I think it's not just for those obvious cases. I think we may be able to use AI for other things that we thought we cannot do anything about. For example, wildfire. Usually it happens and then we deal with it. But what if we could have done something about it in advance through simulation? Or what if we could allocate better resources differently by, I don't know, like being able to free our time from doing certain things and then being able to invest our time for other things? And even democracy. Maybe this is not AI's business, or is it? If we had different kinds of opinion, collating, I don't know, like integrating mechanisms, or somehow people learn about each other's values better. I mean, maybe this is really so hard because humans are humans and we like to disagree with each other, but still I do wonder whether the way that social media has a negative impact for humans' happiness, and does it really have to be that way, or could there be different ways of designing computational systems such that people understand each other better? Like, I wonder whether we could think about these questions more constructively. And one thing for sure, though, if we just leave it to large tech doing benchmark optimization, I don't think these problems will be solved automatically because, say, OpenAI 03 or 04 is better at math. Suddenly other problems are getting better. It doesn't work like that. So it might be that we need to think about other dimensions of human life more actively through the lens of AI.
Okay, thank you, Yejin. Thank you so much for speaking for an hour and for fielding all those questions. Ramyan, I'm so sorry. I think we're going to have to call it right now. I'm just going to wrap things up, but One of the other people who is waiting to ask a question put his question in the chat, so perhaps Yejin can look at it afterwards. But I just wanted to wrap things up for those people who have to go, and to first and foremost thank Yejin for an excellent presentation and a very provocative one, especially on the issue of creativity. It's interesting to hear all the different opinions. Obviously, a lot more to explore in that area. So thank you to the audience. Thank you to Yejin for both of you making this a really interesting discussion.